Good day everyone, welcome back to our lectures. Today we're going to focus on Unit 8, Probability, Grade 12 Mathematics under the CAPS syllabus. So we're going to discuss events, Venn diagrams, tree diagrams, and counting principles. So generally what's going to happen, we're going to talk of probability. So probability of a certain event, let's call it A, it ranges from 0 to 1, which means probability of something happening ranges from 0 to 1, which means you cannot get a probability of -1 or a probability of 2. So it ranges from 0 to 1. So the 0 represents 0% up to 100%. So probabilities that are outside of this range, you know that you've made a calculation error. That's what it means. Probability is always between 0 and 1. Then when you speak of probability of an event A occurring, is favorable outcomes over total outcomes. For example, the most popular example is throwing a dice. So we know that a dice has got 6 faces. There's 1, 2, 3, 4, 5, 6, which are normally represented by dots like these ones, right? Like this, usually like this, like this. So it means the probability of getting a 1, you say number of favorable outcomes, there's 1 over possible ones, there are 6. So the probability will be 1 over 6. So that's what we mean. So when the probability, then we say what is probability of getting a 7? It's equals to 0 because it's impossible. So 0 means impossible, 1 means certain it is going to happen, then 0.5, it's called an even chance. It has got 50% chance of happening, 50% chance of happening, and 50% chance of not happening, right? So the core idea of probability quantifies uncertainty using numbers between 0 and 1. So that's what we are going to be dealing with in this unit. So let's move on. So Unit 8 roadmap. So the unit moves from basic probability to structured counting methods. So we're going to start with basic probability, then you go to Venn diagrams, then you go to event rules, then you go to tree diagrams, then you go to counting principles, then you go to exam synthesis. So our static logic, we're going to start with sample spaces and simple probability. Then we use Venn diagram when events overlap. Then we use multiplication or addition rules correctly in order to solve the probabilities. Then we use tree diagrams for staged experiments. Then for the exam logic, what we are going to do is to identify event language, for example, not, and, or, at once, which means at least once, which means it's one or more. Then we check whether events are mutually exclusive. Then we check whether events are independent or dependent. Then we use counting principles when listing outcomes is inefficient. So all these things are the basic bread and butter of this topic. So let's move on. So basic probability. So when you talk of basic probability, it measures how likely an event is to occur. So as we have said before, probability on event A occurring is the number of favorable outcomes divided by the total number of positive outcomes. Then we know that 0 it means probability. If the probability is 0, it means it's impossible. When 0.5, it means it's even chance. 50% chance. Then if it's 1, then it means it's certain, it's definitely going to happen. So key interpretation. So when probability of event A occurring is equals to 0, it means it's impossible. 1, it means it's certain. So values closer to 1 are more likely. So which means if you get probability of 0.8, 0.9, it means it's more likely because it's closer to 1. Values closer to 0 are less likely. For example, 0.1, 0.2, it means they are less likely to happen. So just like I've shown you before, if you take a fair die, so if you say it's a fair, which means each side has a fair chance of occurring. Something like that. So we say an example of a fair die. So the probability of getting rolling a 4 is 1/6 because there's only 1 4 on the dice. So it's 1/6. So probability of an even number. So even number, we know there are like numbers like 2, 4, 6. So because there are only 3 of these, because you cannot go to 8, 10, because they are not part of the dice. The dice only ranges from 1 to 6 numbers. So the only possible are 2, 4, and 6. So there are 3 outcomes out of 6. Then you divide by 3, then you get half, 1/2. So that's how we get here. So you must remember this formula is very important. Possible outcomes or favorable outcomes over total number of possible outcomes. So let's move on. Then theoretical probability versus relative frequency. So theoretical probability is expected. Relative frequency is observed, right? So when you talk of theoretical probability, it's based on mathematical expectation. So if you have got an example of a fair coin, it means there is head or tail, right? Head or tail. So it means this one has got a 50% chance of happening, and this one has got a 50% chance of happening. So mathematically, the theoretical expectation is half. It's half and half, right? That is from a theoretical point of view. But let's say in reality you do an experiment, right? Then you toss the coin, it has a head and tail. Then you find out that when you throw it, you get certain number of heads and certain number of tails. Then from that experiment, you can have the relative frequency. So as the trials increase, it usually approaches the theoretical probability. So for example, you can throw a coin, let's say 5 times. 5 times. You throw a coin 5 times, then you get head, tail, head, for example. So it means for that experimental throw, you have got 4/5. Probably this is not a probability, we say a relative frequency will be 4/5 because it's event count over trials. So 4/5, which is 80%. So the main difference is the theoretical one is based on mathematical probability. Then the relative frequency is based on the experiment, right? Based on the experiment or of the outcomes that you get. So if we look at the example here, it means if a coin is flipped 50 times, then heads appears 28 times, The relative frequency of heads is 28 over 50. So remember, event count and total trials. So the event count is 28, total trials is 50. Then if you simplify it, you get 0.